Tutor, where school is made simple. Let's go.
In this video, we're going to look at the area of a triangle as it relates to the area of a rectangle. The area of a rectangle is base times height, which if we look at the area of CDFG, we can see that the area is 117.38 square centimeters. Now, how are we going to go about creating triangles within this rectangle? I'm going to first choose a point labeled E on the top edge. I can then move this point anywhere along this edge that I like. And I'm going to look at some triangles we can establish using this point. So if I connect point E with point D and point G, I will see two additional segments created. Now notice that I've created triangles. I have a triangle over here, a triangle over here, and finally a triangle using the entire base. Now, I can create triangles in this manner. And now I have my three triangles clearly identified. And I want to look at the area of these three triangles. So now I see the area of these three triangles, and I want to look at them and see if there's anything that pops out. Well, as I move this point E around, I notice a few things. I notice that these two areas are going to change. The first two areas of triangle CDE and EFG change drastically. But if I notice something curious, triangle EDG down here at the bottom, that area never changes. And I want to look at, well, what's the relationship between all these three triangles and the area of my rectangle? Well, if I were to simply add these up, I would find out that these three triangles added up equal to the area of the rectangle. And once I know that, then I start to find some curious things. What if I looked at the sum of triangle CDE and the triangle EFG? What would that sum be? And I find out that the sum of those two triangles is equal to the area of the third triangle. And no matter what I do, no matter where I manipulate this point E, the sum remains constant as well. And this makes sense in light of our past videos where we show that this triangle plus this triangle equals finally this triangle. So what does that tell us in terms of the area of the triangle? We still don't have an answer to that. Well, let's look at it that if I add these two and get this one, and these two are equal, then I can see finally that half the area of the rectangle is equal to the area of the triangle, which then leads us to our basic formula for triangles, which is that the area equals 1/2 of the base times the height. And that's where the area of the triangle derives from.